And we haven't even discussed higher amp loads like this headlight bulb, which is a whole different beast compared to this 1157 bulb. Now there's a lot of moving parts here and a lot of wires, which can muddle up our thought processes in what was already perhaps a complex troubleshoot. All of this can be consolidated. There's a gadget for that. The gist is that by having everything neatly consolidated on this side of the banana jacks, allows us to focus on the diag that goes on the other side of the banana jacks. It offers 4 load ranges: 0.3, 1.6, 2.5, and a beefy 6.3 amps. These are nominal values at 12.6 volt. The indicator lamp and the resistors don't much care about polarity, right? But these small voltmeter modules do. They have reverse polarity protection. They simply won't light up if the polarity isn't right. Also, there are no batteries inside this gadget. The voltmeter module is powered by the measured circuit itself. Below 3 volts, it goes dark. And that red contrast of that bulb really works out nice. Here we are all the way down to 1.5 volt, and we can still see the glow of that filament. I went with resistors rather than bulbs, and there are a few advantages, one of which is that they're less fragile than bulbs. For another thing, it's heat. I know we're not supposed to put fingerprints on these bulbs, but would I dare touch that as it powers on? We're on the 6.3 amp setting here, which is comparable to that headlight bulb. It invokes this 2 ohm resistor located here in the center. I got my fingers on that. I would never have my fingers on that bulb, right? Now it's going to get hot, like really, really hot. Still okay right now. Now these are high amp loads, and we have to be respectful, and they would be only used in the most rigorous of circuit tests. That 2 ohm resistor will eventually get very, very hot. Now usually we know if the circuit is good within a minute or so, like we test, we get our results, and we disconnect, right? We got about 3 minutes, and this thing will start smoking. Even though it says that it's a 100 watt resistor and we're loading it at 75 watt, about 3/4 of its rated capacity, in time this thing will self-destruct. Now there are no such qualms in the lower 3 more reasonable settings. It can be left on indefinitely. There are 2 main ways that something like this can be used, right? The first, which more readily comes to mind, is that we load the circuit to make sure that it can carry a current. But the second way is to use it to apply power to a circuit, knowing that we're limiting the current to the setting. Left to its own devices, this 1 ohm resistor would draw a lot of current. But if we powered it through this small incandescent test light, we limit it to the 150 milliamps of the test light itself. Same idea, but with a little bit more oomph if we power it with this 2 amp test light. It's limited to the 2 amps of the bulb. And here with the 2.5 amp setting, we're limiting the current. Or at least we're led to believe that we're limiting it to 2 amps. Bulbs are not resistors. They will have a current spike profile. How significant? Like, is it 10%, 20%? Let's measure it. So I've got a bit of a rig going on here using the HS502 in scope mode, trigger method. I discussed that 2 videos ago. So here's a practical demonstration of that capture mode. The instant the circuit is complete, the capture will take place. And look at that. It's not like 10% or 20%. It's fourfold, right? Same thing. When the circuit is complete, the capture will take place. And we have no such spike. The resistor climbs up to its expected draw, amp draw, and levels off. Now this variable load test light gadget is a hybrid. It has a small lamp which will have that spike characteristic, but it'll be tempered by resistors that do not. Let's have a look inside. Notice my trademark use of 14 gauge solid copper NYMEX wire in the build of this resistor pack. The high load, high heat 2 ohm resistor was intentionally nestled right here in between the other two resistors. There was quite a quest for a rotary switch that would be cheap, not too bulky, and could handle the 6.3 amp load. It's a 2-pole switch in a single pole application, and I was able to cheat by using the 2 wipers and the 2 contacts of both poles for that 6.3 amp load. Works out great. I share everything, that diagram, the STL files, and a parts list. Now this channel is strictly DIY. I do not build any of the gadgets for sale. I'm much too lazy for that. And I wouldn't want to deprive you of the satisfaction of the build. It's half the fun. The other half is to be able to add these to your Diag arsenal. So help the channel out, give it a like, subscribe if you haven't, and we'll catch you on the next project.